When two secants intersect, I like to remember pow-pow as a way to remember what to do. Pow-pow stands for the part outside the circle times the whole thing, and then of course the same thing over here, part outside times the whole, P-O-W. Here's what it means in terms of the circle. So I've got these secants drawn down here. Recall that secants are lines or segments that intersect a circle 2 times. So I have part of the secant that's drawn outside of the circle, and then I've got the whole secant. And so what we're going to end up doing a lot with these problems are drawing in these brackets to indicate the whole segment. Notice this piece right here, the piece inside, is not used when I set up pow-pow. It's the part outside times the whole. We'll set that equal to the part outside down here times that whole secant. So kind of the big thing to remember is drawing this bracket in. So let's take a look at how this is going to work. So here are 2 examples where 2 secants intersect. Let me actually set this up wrong first. What I see a lot of people do is they kind of think back to the chord example if you watched the previous video, and they just multiply these 2 pieces together. 9 times 6 is equal to x times 5. And if you do that, you will be wrong every single time. That absolutely will not work. Instead, what we need to remember is pow-pow, the part outside times the whole thing. So what I want to do first is draw in these brackets to find out the whole length of this segment. 9 plus 6 is 15, so this entire segment is 15 units long. I can do something similar down here. This entire secant, if I add those pieces together, is going to be x plus 5, or 5 plus x, but not 5x. I see people do that. 5x means 5 times x, and that's not what we're doing. Okay, so now that I have this set up, let's set up our pow-pow equation. It's the part outside the circle, which is 6, times the whole thing, P-O-W, part outside times the whole. So 6 times 15, notice that 9 is not used in our equation. I'm going to set that equal to the other part outside the circle, which is 5, times that entire secant, which was x plus 5. Once again, notice that single x was not used in there. We're not using the part inside. Okay, so this is the setup that we want to use. 6 times 15, if I go ahead and solve this, is 90. And then I'll remember to distribute over here 5x plus 25. The algebra is the easy part. It's setting up these that can be a little bit tricky using the geometry. So I'll subtract 25 from both sides and get 65 equals 5x. And then of course x is equal to 13 once I divide. Okay, let's go ahead and try another example. This would be a great time to pause the video and make sure you've got this idea down. Once again, the very first thing you'll always want to do on these problems is very first draw that bracket, and you need to know how long the whole secant is. Adding those pieces together, then 22 plus 18 gets me a sum of 40. So that whole secant is 40. This whole secant down here is x plus 20 once I add those pieces together. Remember, you're not using these parts inside the circle, so get rid of them. It's pow-pow, the part outside, 18, times the whole thing, which is the bracket, times 40, is equal to the other part outside, 20, times the whole thing, x plus 20. Okay, so let's go ahead and solve this then, multiplying this out. 18 times 40 is 720. And then I'll remember to distribute on the other side, so 20x plus 400. Okay, the algebra should be the easy part. Subtracting 400 from both sides is 320, equal to 20x, and finally dividing both sides by 20 gets me an answer of 16.